Hello guys, this is our laboratory activity for the grid. So first, let's turn this on and then let's go here. Let's prepare the materials that we will be needing. So we are going to use a 14 by 14 size of image receptor or cassette, which I already placed on top of your radiographic or x-ray table. It's 14 by 14. As you can see, it's square, right? Then we are going to use your anthropomorphic head phantom, or head phantom for short. And then for this one, guys, what we are going to do is we are going to take a radiographic exposure of this head phantom. First is with the use of a grid, which is, in this case, situated under your x-ray or radiographic table. Okay? Then the other one, guys, it's still the same. Same radiographic exposure of this head phantom, but without the use of the grid. Okay, so let's start. First is, we're going to place it here. Then let's close it up. We will place the head phantom. And then we're going to collimate. Okay, there you go. And then we are going to choose the factors. For this one, I will be using 87 kVp and 7.1 MAS. And we are going to expose it. Alright. Next one, guys. Next is still the same. Okay? Still the same setup, but we will not be using any form of grid. So we will be directly exposing this one on top of your image receptor. So it's still the same. There. Let's just place it here, guys. And then we will place the phantom. Alright. Yes, guys, the phantom is heavy in person. So you'll get a chance to play with this one here. Hopefully by next semester. Still the same. Same size of the collimation, same everything, and then same exposure factors, as you can see. And then we are going to expose it. Hello guys, we have here the finished radiographs for both exposures. So let's compare them. Okay. This is exhibit A, or radiograph A, and this is radiograph B. As you can see, guys, both have the same technical factors used in taking these radiographs. 87 kVp and 7.1 MAS. Now, what can you say about the image itself? What can you say about the image itself? You have to bear in mind, guys, that in order to eliminate or reduce the scatter radiation produced, we collimate the beam, right? Beam restriction. We'll go back to that topic. Beam restriction. We collimated both. We properly collimate on both radiographs, on both exposures, right? But if we're going to look at this one, guys, the image still looks like this as compared to this one. But on this image, we properly collimated this image the same as this image, but what's the difference? We used a grid for this image. And as we all know, a grid is a device that is used to absorb the scatter radiation produced. And because of that, when that scattered radiation is produced, contrast is improved. When you say contrast, it's the difference between densities. right? So can you say, or can you see for yourself, guys, that this radiograph has a better contrast compared to this radiograph because we've used a grid on this radiograph? Okay, let's zoom in on these structures. Try to compare these structures here to these structures. See? By employing the use of a grid, the production of scatter radiation, guys, or the scatter radiation is reduced here for this radiograph as compared to the scatter radiation here, because we've used grids. Therefore, in return, the contrast for the radiographic image here is increased. So that's all, guys. Hope you've learned something from me today.